Hello grade 6 students, our lesson today is symmetry. The objectives of our lesson are: define point of symmetry and axis of symmetry, draw axis of symmetry, draw symmetric figures with respect to a center of symmetry means symmetric with respect to a point, draw symmetric figures with respect to an axis of symmetry means symmetric with respect to a line, and to practice. What is symmetry? An object is symmetrical when one half is a mirror of the other half. Symmetry keeps the same size and shape. For example, the symmetry of a triangle is a triangle, of a segment is a segment. They have same size and shape, and of a circle is a circle. Types of symmetry. We have center of symmetry and axis of symmetry. When you trace a heart onto a piece of folded paper and then cut it out, the two half hearts make a whole heart. This folded line is called axis or line of symmetry. We can see that the two halves, this half and this half, are symmetrical. A line of symmetry divides a figure into two identical parts. It can be vertical, like this case, or horizontal or diagonal. Center of symmetry. What is a center of symmetry? It's a point within a figure. It exists when the figure is drawn around a single point. For example, in a circle, square, star, and octagon, this is the center of symmetry in each of them. How to draw A prime, the symmetric of A with respect to O? We have to use the ruler or the compass and take O as the midpoint of segment AA prime. This is point A and this is point O. First, we are going to use the ruler to measure the distance from point A till point O. We can see that it's equal to 5 centimeters. Then, the distance from point O till point A prime is equal to 5 centimeters as well. Then, AO is equal to OA prime equals 5 centimeters. Remember, if A prime is the symmetric of point A with respect to point O, then O is the midpoint of segment AA prime. Note, symmetry of point O with respect to O is O. Let us take application on axis of symmetry. Isosceles triangle, it has one axis of symmetry. The rectangle, it has two axes of symmetry. Equilateral triangle, it has three axes of symmetry. This square has one, two, three, four axes of symmetry. The parallelogram has no axis of symmetry. And the circle, it has infinite number of axes of symmetry. The axis of symmetry cut the figure into identical and equal parts. How can we draw an image of a figure? The image of a figure is the reflect of the same figure with respect to a point or a line. Let us take an example by drawing the image of a figure with respect to a point first. We have triangle ABC. We are going to draw its image with respect to point O. First, we join the 2 points A and O and measure the distance between them. This distance has to be equal to the distance between point A prime and O. Second, we join the 2 points B and O and measure the distance between them. In the same way, this distance has to be equal to the distance between points B prime and O. And finally, we plot the image of C, which is C prime. And at the end, we join A prime, B prime, C prime. Now, Triangle A prime B prime C prime is the image of triangle ABC with respect to point O. A prime is the symmetric of A with respect to O. B prime is the symmetric of B with respect to O. And C prime is the symmetric of C with respect to O. We can notice that O is the midpoint of segments AA prime, BB prime, and CC prime. Now let us take an example by drawing the image of a figure with respect to a line. We have this triangle ABC. We are going to draw its image with respect to line D. First, we draw a line perpendicular to D passing through point A, and we measure the distance from point A till line D, and we take same distance from point A prime till line D. Second, in the same way, we draw a line perpendicular to line D passing through B, and we measure the distance from point B till line D and take same distance from point B prime till line D. And in the same way, we plot the image of C, which is C prime. And then we join A prime, B prime, C prime. Now, triangle A prime, B prime, C prime is the image of triangle ABC with respect to line D. A prime is the symmetric of A with respect to line D. B prime is the symmetric of B with respect to line D. And C prime is the symmetric of C with respect to line D. We can notice that line D is the perpendicular bisector of segments AA prime, BB prime, and C prime. Let us take an example by finding the symmetric of a figure with respect to a point or a line. Given square ABDC, the diagonals AD and BC intersect at point O. Points G, F, H, and E are the midpoints of segments AB, BD, DC, and CA, respectively. We are going to find the symmetric of triangle AEO with respect to point O. In order to find it, we have to find the symmetry of each point alone one by one. The symmetric of point A with respect to point O is point D, since O is the midpoint of AD. The symmetric of point E with respect to point O is point F, since OE is equal to OF. And the symmetric of point O with respect to point O, it's the same, which is O. Then the symmetric of triangle AEO is triangle DFO. Now we are going to find the symmetric of square AGOE with respect to point O in the same way by finding the symmetry of each point alone. The symmetric of point A with respect to point O is point D. The symmetric of G with respect to point O is point H, since OG is equal to OH. The symmetric of point O with respect to point O, it's the same, which is O. And the symmetric of point E with respect to point O is point F. Then, the symmetric of square AGOE is square DHOF. And we are going to find the symmetric of segment FD by finding the symmetric of points F and D one by one. The symmetric of point F with respect to point O is point E, and the symmetric of point D with respect to point O is point A. So, the symmetry of segment FD is segment EA. Now we are going to find the symmetric of triangle AEO with respect to line BC by finding the symmetry of each point alone. As we know, in order to find the symmetry of a point with respect to a line, we have to draw a line perpendicular to line BC passing through this point. First, we have to mark line BC, and the line that is perpendicular to BC passing through the first point, which is A, is this line. Then, the symmetry of point A with respect to line BC is point D. The symmetry of point E with respect to line BC, in order to know it, we have to draw a line perpendicular to BC passing through point E. So the symmetry of point E is point H, having the same distance away from BC. And the symmetry of point O with respect to line BC, it's point O, since O is located on line BC. Then the symmetry of triangle AEO with respect to line BC is triangle DHO. And now we are going to find the symmetry of square AGOE with respect to line BC. In the same way, by finding the symmetry of each point alone. The symmetry of point A with respect to line BC is point D. The symmetry of point G with respect to line BC, in order to know it, we have to draw a line perpendicular to BC passing through point G. So the symmetry of point G is point F, having the same distance away from line BC. The symmetry of point O with respect to line BC is the same, which is O, and the symmetry of point E with respect to line BC is point H. Then, the symmetry of square AGOE is square DFOH. And we are going to find the symmetry of segment FD with respect to line BC, starting by point F. The symmetry of point F with respect to BC is point G. And the symmetry of point D with respect to line BC is point A. Then, the symmetry of segment FD is segment GA. As I told you before, the symmetry of a triangle is a triangle, the symmetry of a square is a square, and the symmetry of a segment is a segment. In order to practice, solve the following. Stay home, stay safe, and have a nice day.